So at the bottom of page 698, they give you the following formula. Permutations of different objects. Now, again, for the most part, we're going to be doing the fundamental counting principle for this. For example, a simple question of permutations of different objects would be 10 people are running in a race. How many ways can they finish first, second, and third? So if we were doing spaces for this question, 10 people running in a race, how many ways can they finish first, second, and third? We have 3 decisions that we have to figure out. First place, second place, third place. And of the 10 people, how many could come in first? You have 10 choices that could go there. Then how many people could come in second? 9, then 8. And the majority of our questions, we are going to do this. But there's a formula for this. The formula for this would be 10PR. And this is in your calculator as well. But what does 10PR mean? Well, according to this, we have n distinct objects, so that's our 10 distinct people running in the race, and we're trying to arrange them r at a time. In our case, we're trying to make an arrangement for 3 of them, first, second, and third. When we have this number basically stands for how many spaces we have. And this is the starting number. So 10p3, 3 spaces start with 10 and go down 1 each time. That's what the formula means in a quick way. Using the actual formula, the formula says it's n factorial over n minus r factorial. So if this is my n, I would have 10 factorial on the top over 10 minus 3 factorial on the bottom. Well, this is the same as 10 factorial over 7 factorial. And you're not going to multiply out 10, 9, 8, 7, 6 all the way down to 1, because if you wanted to simplify this, we could expand 10 factorial, be 10 times 9 times 8, and when I get to 7, it keeps on going, right, all the way down to 1. But I could say, I'm going to stop there and say 7 keeps on going down to 1, because I'm dividing by 7 factorial. And then those disappear, and we just get 10 times 9 times 8, which gives us our 3 spaces and our 3 numbers. But for the most part, these questions will be easy enough to think about with our fundamental counting principle that we will rarely use the permutations formula. It's on your formula sheet. It's in your calculator. So you go to your calculator. You can go 10 math over to probability, the same place. And then there's NPR, the second one. 10P, and then you can plug in 3, and you'll get the same answer, 720. So when we go here to example 2, 8 students competing. How many ways can they finish first, second, third? I should have picked an example in the previous one that wasn't almost identical to this one. But as a spaces question, first, second, third, 8 choices for first, 7 choices for second, 6 choices for third. This is equal to 8p3. So you could type that into your calculator and figure out what that would equal to, 336 again. Okay? I didn't give you questions for the first one, right? Did I forget to do that? So for the first one, you could do 3, 5, and 9. And for this one, you can do 4, 6, 7, and 8. So basically you've got all the questions 3 through 9 so far. And has the tree question been giving you a headache? Do you want another hint? It is a sequoia. Oh, nice. Has all 5 vowels and the shortest. Well, apparently there's like I think there is a word that just uses all 5 vowels that's 5 letters long, but I don't know if it's really a word. He Googled it, Iouia, it's some sort of amoeba. Okay. So here's another puzzle for you. What is a word that starts with he, ends with he, but isn't he? Because that would be the easy one, right? Oh. To make it worse, I use the word in the last 30 seconds. Oh. See, now you have to start rewinding, right? We'll listen to the video over and over again to find it out. Trying to get my views up. I don't know if this is going to work.